Welcome back to another exciting chemistry lesson. In this lesson, we are going to look at substance in a liquid state. Now, in a liquid state, atoms and molecules are interacting with nearby molecules, and they are moving past one another. To illustrate this definition, we have to look over here. Here we have molecules or atoms. They are in liquid state, and they interact with nearby molecules. As you can see here, they interact with nearby, and these molecules are moving past one another. Okay, so let's look at the different properties of liquid as we are going through and look at in terms of intermolecular forces. So here are the common properties of liquid that also increases as the intermolecular forces increases. When we talk about intermolecular forces, we are talking about the forces between the molecules, okay? So we're talking about how strong are they holding together. The greater the intermolecular force, the greater the strength between the molecules holding together. First thing first, we have melting point and boiling point. It makes sense. As you increase the strength holding the molecules together, you would have a higher melting point and boiling point. So, greater intermolecular force led to greater melting point and boiling point. With increasing intermolecular forces, we also have increased surface tension. By definition, that is the ability of the surface of a liquid to resist external forces, okay? So it makes sense. The greater the attraction between the molecules, it's harder to break that tension. Then we also have viscosity. So the greater the attraction between the molecules, the greater the intermolecular forces between the molecules or atom, the viscosity would be higher. That is, the greater the resistance to flow. Think of honey versus water. Honey has a greater intermolecular force. It has a greater viscosity, which is it has a greater resistance to flow. And then we have heat of vaporization. If you don't know what heat of vaporization is, by now you should know what is vaporized. Think of vaporization. That is to evaporate a substance, right, from liquid to gas. So think of that way, from liquid to gas. Think of that way. So of course, the greater the interaction between the two molecules, the greater the intermolecular force, the greater the heat of vaporization. So once you memorize these facts, again, there are a lot of questions that can ask you about this specific topic. The hardest part is memorize this little basic thing and apply it in different situations. And that's the hardest part as you are trying to solve in the later problems. So these properties increases as we increase intermolecular force. But there are other properties that decreases as we increase intermolecular force. One of them is vapor pressure. So vapor pressure decrease, and by definition, vapor pressure is the pressure exerted by a gas when it is at equilibrium with its liquid, okay? So vapor pressure decreases as intermolecular force increases. Volatility. Volatility is basically the ease of vaporization. If you think about it, the stronger the interaction between the molecules, so it would be harder for a molecule to evaporate, because they are holding together very strongly, or in this case, they attract together very strongly. And one last information that we have to look at in terms of molecular forces and their properties is, how is this related to temperature? Well, increased temperature will decrease intermolecular force. Think about it. When you increase the temperature, you increase the average kinetic energy, and that is basically the energy of motion. So the more it moves, the more it vibrates, the more it moves past one another between the atom. Of course, now the chance of the molecules to be farther apart will be much greater. And that's the reason why when we increase temperature, we decrease the intermolecular forces. And you have to remember this really well, because the term increase and decrease will be switched, and they will be having the opposite effects, right? So if I change this to decrease, these properties also decrease, but the property here increase. You see how that works? So make sure you take the time to review the facts and memorize it, because you will be given different situations, and you just have to know these facts to apply in those situations. Now, the last part of this lecture will be ranking the intermolecular forces based on the different types of substance. It's obvious that the substance with the strongest intermolecular force is ionic substance because they completely transfer that electron and give you that complete charge between the cations and the anions. But for covalent substances where electrons are being shared, which in this case, if they are different in electronegativity, you will have a dipole in terms of that molecules, right? We have the polar molecules. It's get really tricky when we look at substances that are covalent. If that's the case, we have to look at other things: hydrogen bond, dipole-dipole, and London dispersion force. Before we apply these facts, where hydrogen is greater than the dipole-dipole, which is greater than London dispersion, all molecules has London dispersion force, LDF. And the greater the molecules, which means the larger the molecules, and which we look at based on their molar mass, the greater the London dispersion force. Now, before we do anything, okay, we have to look at the size of the molecules. Before we apply this, we have to realize that size are similar, so they have similar atoms, and they have similar molar mass. If that's the case, hydrogen bond is stronger, followed by dipole-dipole forces, and then followed by London dispersion. But in some cases, when we have a very large molecules, or the strength of London dispersion force is even greater than hydrogen bond on dipole-dipole forces. So keep that in mind. The size of the molecules is extremely important. And on your question, on your test question, sometimes we give you data that show a molecule that is non-polar, but it has a greater intermolecular forces. You have to realize the reason behind that it is London dispersion forces, and that is the secret. Look at the size of the molecules. And part of your answer, in order to get the full credit, you need to include that the size of the molecules is large, so therefore London dispersion force is greater than even hydrogen bond and dipole-dipole intermolecular forces. So the challenge of this topic is that you have to memorize these basic facts, because there are so many variations of questions that allow us to manipulate the information and apply one bit of information at a time. So you will see that in the practice problem as you look at different type of question relate to different properties of liquid, relate to intermolecular forces. And as always, if you have any question, take a picture of your work, put in the forum, and we will help you from there. And we'll see you next time on another exciting chemistry lesson.